Hello everyone. So today we will make a video about how to use the SFC14 and SFC15 in Semantic Manager to communicate with the Profibus devices. So this is a common function block, no function SFC that we normally see in the program to get the values from Profibus slaves, like the example that we have here. Actually, this is my setup for today. So I have a S7 400 PLC, and my Profibus device slaves are this is an absolute encoder, and this is IM153 8200 M station. Then I have a G120 Dynamics drive, and I have an ABB ACS880 drive. So today I'll show you how we can use SFC14 to get the values from, for example, from ABB, from Dynamics, and from this encoder, and also how we can write the values from PLC to drive or PLC to the Profibus device through SFC15. So we will go to the program. So today, as a starting example, I'll be using ACS880 to show you how we can do it. So and before going before doing the program, we need to make sure our hardware configuration is properly downloaded, and just go online and see if your all the devices are working properly. So all my devices are okay. I have no fault. All the 4 devices are working properly, and we will start our example with the ABB CS880 drives. So okay, so as you can see here, my input address start from I528 and it ends at 538. So I have 6 inputs and 6 output, and the I528, the one the input is a word in word format, that is a 16-bit format. You can see 16-bit, which means it is 2 bytes. So my input 6 words means I have 12 bytes, and similarly I have 6 output, which means I have 12 output bytes. So now this one I think you need to understand clearly that why I said this. I will explain this. Anyway, this is our setup. So we'll go to the program. The first thing, we will make a DB. uh, as we are talking about the drives, we will first configure a DB with the first word we will convert into 16 bits for our status word, and this is our status word. This is the speed feedback, and this is the DC bus voltage. This is the motor current, and this two I am not using. So this all we need to configure in the DB. And output, this will be the command word, 16-bit command word, and this will be the speed reference, and these three I am not using anywhere. So let's create a DB with the according to our requirement. So I already made one DB here. DB1. Okay, so as I told, the first word, this is the status word. So status word start from 0.0 to 1.7. So from this is 2 words, 2 bytes to form the one word, which is the status word, and the second one is the speed feedback. I have configured as integer. Then DC base voltage. Then motor current, and these two I am not using. So I just made like input 5 and input 6. Okay. Now the status word, you can see, you can download the manual and you can do yourself, like this is the status word. And always remember, when using the ABB or Dynamics, there is always a byte swap. So the first 8 bit you need to configure first. So first 8 bit, it start from at set point, yeah, 8. So this will be the first byte. Since it due to a byte swap, we need to configure the second 8 to 16 bit as the first byte. Similarly, the first byte of the status word you need to configure in the second byte of the DB. Okay. So this, I think I have explained in the other videos. You can check if you like. And the output side. So we configured the 6 input words in the DB exactly as we configured in the drive. Now the output. Output, as you can see, the control word is my first output. So my first output will start from here. Okay. So the input section is done. The output. So again, if you check the manual, you'll find the first bit is of 1, of 2, of 3. But due to the byte step, you need to start from here. So 8 to 9 is drive specific, which I have configured as the first input. Then remote command. So all this I have configured, and the actual first bit of the control word will come in the second byte of uh, where we are configured. So you can see often start from the second byte. Okay. So 13.0, 13.1. Okay. And so this is done. Now the speed reference. So speed reference will come here. Okay. Then the rest I am not using, so I have just configured it as pair output. Okay. So now this DB1 is done. So we will close this and we will go to the program. Okay. So so this is the control word. So I have IM153. I have this inputs available. So I'll be using this I0.4 as my always high bit. Means I need to, for example, I can use this bit to make some variables true. And I will use I0.6 to start my drive. Okay. I0.6 to start the drive. So to start the drive, I will be using this off on control to start the drive. So off on control is configured in my DB. You can check in my DB. Off on control. Yeah. So it start from 13. That is db1.dbx 13.0. So my control word start from here up to 13.7. Then the second byte of the control word start from here 12.0. So I have configured exactly the same way in the program. You can see this is the start command. So this is db1.dbx 13.0. Okay, and these are the control word. So I0.4 is always high. So I make all this true, like of 2, of 3. Then you can check in the manual of 2, of 3. Then inhibit operation. All this I have made it true. Then reset 13.7. Okay, this I have made a memory variable. If I want, I can force this and reset the drive. So that's it. So the control word is same as you can see in my other videos. I have made a video for how to communicate with ACS 880 drive using S7 PLC. You can check. You can see the full explanation of this. Today we will be concentrating on SFC14 and SFC15. So let's configure. So insert network. So you can type SFC14. Okay. So this is our SFC14 for drive to PLC data transfer. Okay. Now you can see a couple of parameters here. So here is where you define the address, and the address should be defined in hex format. So how to configure the address is like you need to go to your hardware configuration. So now I am going to take the value from ABB drives. So you can see my address start from 528 to 539. Okay, 528 the input ends at 539. Okay, so I have 6 words, which means 12 bytes. Okay, so you need to find the hex format of 528. So use the calculator. So 528, the hex value is 210. So what we will do is in the program you need to define w hash 16 hash 210. So this is your uh, address for receiving the value from the drive. Now the return value is again important to diagnose, like if you have a error using this block, it gives an error code. So this error code is really important to understand what is the problem. So let's move to MW300 or any value. So now we have 6 words, that is 12 bytes coming from ABB drive input. Okay, now we need to so you'll receive the value from here. Now we are going to move to our DB. So this is the format to do that. P hash db1 dot dbx 0.0 by 12. So this means that db1, uh, let's take, you can note down db1 dbx0 means from 0 to up to 12 byte will be transferred from the input to this db. So we'll open the db. Okay, so our input start from here, dbx 0.0 to 12. Okay, till 12 we are using as an input to transfer the drive to db. Okay, now our uh, output start from, you can also see from 12.0. So when you define in the program, so our input section is done. Now then new network, PLC program. So we'll be using SFC15. So our address is same because it is the same value, like input address start from 528, output address also start from 528. So hex of 528 is still the same value. So we use that, and the address. So from where we are going to write to the drive. So as I said, in the DB, it in the DB the output starts from 12. okay, and it's we have 6 words, so it will be again 12 bytes. So we configure that. So p hash db1 dot dbx 12.0. How many bytes? So byte 12 bytes. Okay, so again this is the diagnostic value, so I'll give MW302. Okay, so that's it. So now by using this function I can read from drive, and using this function I can write to the drive. Okay, so let's download this DB first. Okay, okay, so as you can see uh, uh, my SFC function is executed, means I don't have any error over here. So this error, it's a bit tricky to find out. Like for example, let's say you configured a wrong value here. Let's say I configured 10. Okay, you can see that my SFC is not executing, and you can see an error code here. So this error code, you need to, if you click F1, it will go to the help file, and you can see the error codes here. And as you can see, it has no matching with this number. So this number is, again you need to convert to hex. So you use your calculator and enter this value. So minus 32591, and you'll get a hex code of the last 4, so 80B1. So you can check here, what does 80B1 means. It means that length of the specified destination area is not identical. Yeah, correct, because our destination is from drive, and it has 12 bytes, and I have put only 10 bytes, so definitely it will not match. So that is the error. So you clearly know why the using this error code. So I'll put back to 12. Okay, so now my SFC function is working properly. So you can see how the DB is like. Okay, so I'm already receiving the values like uh, you can see. So this is my status word. So my speed feedback is 0. My DC bus voltage, it is in hex. This is in decimal format. So and motor current is 0. Okay, so now we will start the drive. So for starting the drive, again the it's from the program directly. As you can see, I 0.6 will start the drive. Okay, so I'll give the command. Yes, so the start command is done. So now we will give a speed reference. So let's load. So let's load NW100, then load 200.0, because we need to multiply with 200 to get the value in percentage. So I'll be entering 0 to 100%, means I can give like 20-30%. I can do give the value in MW100, and I will multiply by 200. and I will transfer to the speed reference. So the speed reference is speed reference. So dbw14. db1 dot dbw. Okay, so now let's download this. MW100. Let's try 20%. Okay, so I'll give a start command. Now my motor will run in 20% feedback. Mm. So once I get this, give the start command, you can see this speed feedback here. So I'll give the start. Yeah, so the motor is running. So if you divide that speed feedback by 200, you will get the value in percent. So we are running at 20% speed. Okay. So this is how we make the program using SFC, and we can show. I can show you another example. Like let's now we will take the value from encoder. So the encoder value is 512. So use the calculator. 512, and the hex value is 200. And we minus 304. And I think we'll put directly into a memory variable. So no need of db. And 320 byte 4, because if you see here, I have already two words, so 4 bytes. Okay, so we will see. I have some value from the encoder coming. We will check if we can get it on the in the program. So let's download. Make sure. So as you can see, I have some error. Okay, the address is not correct. So address is 200. Okay, so I have no error. So now my value will be coming at MW320 and MW322. So let's see. Uh, So I have the same value coming. Okay, 5. Yeah. So the advantage of using this SFC block is like when you have multiple drives, you don't have to write same program for multiple time. So what we can use, I'll show you some tricks. Like what you can do is, now let's say you want to take the values from this drive, Synamics drive. So the status word and control word is almost same. So what we can do, we can use the same db. Okay, I'll copy, paste it, rename, and let's save it as db2. So my db2 has the same values, means I don't have to write again and again. I just copy this. Now what we'll do is check the address. So the address starts from 540. So let's convert 540. So it is 21C. Insert. So 21C. Okay. The value MW308, and this one db2 dot dbx 0.0, again byte 12. What happened? db2 dot p hash. Okay. I think I did download the db. So let's db2. Yeah. So I already have the values coming from the Synamics drive. So this is the advantage of using the SFC and the DB, so that you don't have to write the program multiple times. You can use the same DB, copy paste, and use it for the next one. So I hope this was clear how to use the SFC. Okay, so this is the program, and so thank you for watching the video. Thank you so much.